Okay, the last step in this YouTube for constant velocity is to write some equations down. So let's go back to, again, this first motion diagram, the one starting at the left going to the right with a positive 2 meter per second constant velocity. And we want to write an equation for position and for velocity. And actually we'll do all three: position, velocity, and acceleration. So let's go ahead and again just rerun the curve here. I've got the man set in minus 10 meters position, and the velocity set at plus 2 meters per second constant. And the acceleration is set at 0 meters per second so there's no change. So here we go. We've seen this curve before, so I'll go ahead and just regenerate it, and then we'll write the equation down for the position first of all. And so let me do that up top here. Alright, so the position, I can just write on top of here, for this guy is going to be x of t. This is going to be in meters. Units are going to be in meters. Is equal to, okay, so we know that the velocity is plus 2, but that he starts at minus 10, and so his position is going to be, as a function of time, is going to be minus 10 plus 2 times t. Okay, so this right here is the velocity, and this is in meters per second. And this right here is the time, and so this is in seconds. And so what the 2t does is in every second, so when t is equal to 0, x of 0 is equal to minus 10. You can see by putting the numbers in. Let's actually write that down. So we're going to say x of 0, and we're going to have a special notation for that. That's going to be x naught is minus 10 meters, meaning that he starts at minus 10. But then as t starts ticking up, when t is equal to 1, 2 times t is equal to 2, and minus t plus 2 is minus 8. And so x of 1 second, let me actually put the units in here, is equal to minus 10 plus 2 meters per second times 1 second, which is equal to minus 8 meters. And so he has moved 2 meters to the right. Okay, so that's the equation for this line right here is this right here. You can also think of this in terms of y equals mx plus b. The y-intercept is minus 10. You can see it right there, and the slope is 2. Okay, so what's the story for velocity? Well, the equation for velocity is simply, for this particular case, is simply v of t is equal to 2. And then, of course, that's in meters per second. Meters per second. And the equation for acceleration is 0. It's not changing, and so 0 meters per second per second. Okay. So now let's look at the second scenario here on the bottom. And to do that, let me go ahead and reset this. And we're going to set this guy over on the right, and we're going to set this to be minus 2, and again just quickly regenerate the plot. And so here we go. Again, we've seen this before. We're just going to write down the equations for each line that you see there: the position, the velocity, and the acceleration. Okay. Sorry about that. I forgot to take the walls away. Down here, let's do the same thing. The x of t for the second situation. So he starts at 10. So I'm going to put 10 in. And again, that's the units for that is meters. But he's going to the left, and so now the equation is minus 2t. And so the minus 2 corresponds with the minus 2 meters per second. So the units for that is meters per second, and the units for t in seconds is seconds. And so again, if you put some numbers in, if you look at x of 0, which we're again going to call x naught, well, if you put t equal to 0 in here, you get 10 meters. Well, that's his starting position. And x of 1, doing the same kind of thing that we did above, x of 1 second is equal to, putting the numbers into this equation, 10 meters minus 2 meters per second times 1 second is equal to 8 meters. And so 1 second after start, the man is at position 8 meters, 2 meters to the left of where he started at 10 meters. And so he's moving in the negative direction. The minus 2 is the slope of this curve right here. And the similar equation for v, corresponding to what we did up here, is v of t is minus 2 meters per second and constant. And since the velocity is not changing, the acceleration is 0 meters per second per second. So we really haven't let acceleration kick in yet. We're up to this point just considering zero acceleration. And the next thing to do is to look at acceleration. Okay, so you now have a representation in terms of motion diagram, plot, and equation. 3 different representations. So we're going to need to be conversant in all 3. I could give you one and you should be able to give me the other 2. The least precise are the motion diagrams because they don't really show you what's happening at intermediate positions. But they are the most intuitive. And so generally when we teach this material, we start with motion diagrams and then progress to the other representations. So the most mathematically precise are the equations, and these graphs are intermediate between the two.